Okay, is your time. We can keep going straight on down the line. Yesterday, we worked with balancing and classifying chemical reactions and finishing them as well. So, is that something that you wish to continue? Is reactions. Okay. So, moving forward then, we've got running out of room here, but you get the idea. Okay. So give you a couple moments to write that down if you choose to do so. So what type of reaction would you be led to believe that this is? So is this a element, molecule, or compound? That's a compound. Element, molecule, or compound. Okay? So if you have two compounds together, only reaction that could be, well, it could be a combustion as well. But how can we eliminate combustion? Yeah, it doesn't have a hydrocarbon. And it's not combining with oxygen, and it's not giving off carbon dioxide and water as byproducts. Okay, so the symbol for iron is what? Okay. So then the hydroxide ion. You might have said it over here. Okay. So we always say start with your negative ions. Hydroxide has a charge of negative what? -1. And you don't have to guess what iron has for a charge. What is it? Roman numeral 2 is telling you that you have iron with a +2 charge. So again, that does not add up to 0. Okay? What's your least common multiple? Now, someone said 2, which is correct. 2 divided by 2 is 1. We've got 1. 2 divided by 1 gives us 2. This isn't quite correct, though. Okay? Because hydroxide is both of these elements together. That's why it's a polyatomic ion. So we want 2 of this whole thing. Okay? Now, the reason that we say that is different is this. Okay? This is in hemoglobin in your blood. That's how oxygen binds to the hemoglobin in your blood so it can be carried throughout your body. So then in this case, we know iron's got a +2 charge. Oxide, which is just oxygen, has a charge of -2. So that adds up to 0. Because remember, this is a monoatomic ion, this is a polyatomic, and that's what the difference would be then. So we want two of this whole thing, because we have one hydroxide, but we want two hydroxides. So from prior knowledge, how do we illustrate that? Parentheses. Maybe you're talking to your classmate, but that's still correct. Okay? We put parentheses around this, and that's where your 2 goes. Okay. What is the symbol for our calcium? Okay. And then what is the phosphate ion? Well, it's got phosphorus in it. Okay. It's got oxygen in it. Okay. Go by the charge of a negative ion, and phosphate has a charge of negative what? Do we know? Okay, what does calcium have for a charge? Okay, so we can get rid of this. I believe everyone would have that wrote down. That does not add up to 0. What is your least common multiple between 2 and 3? Okay, so then when you say 6, that is correct, and there's nothing wrong with doing this. Okay, and the answer that you get from that division tells you what to put below. Okay, so 6 divided by 2. 6 divided by 3. And again, this is one phosphate ion, and you correctly said that we need 2 of them. Okay? So do you just want me to tell you what you do, or do you want to tell me what you should do? Okay? Why would you do that? Because that's right. Because remember, we have one phosphate ion. We want 2 of them. Okay? Now, that gets to be a little tricky when we say you, and that's what you requested, you tell us. Because if we didn't know it now and we come across this again, then you might not know it the next time, or the next time, or the next time. So that's something to be aware of. All right? So since these switch, 2 positive ions cannot bond together. So which positive ion would you like to start with, iron or calcium? Okay. So then what does the iron bond to from this compound but on our product side? Okay, so it has to bond to the phosphate. Okay, and then plus 2 minus 3, because the charges will not change. So since we had 2 and 3 here, our least common multiple will still be going to be 6. 6 divided by 2 gives you 3. 6 divided by 3 gives you 2. Okay, and then what is the calcium going to bond to from this compound but on our product side? Okay, so therefore we have calcium and then hydroxide. Plus 2 minus 1, least common multiple is 2, and that's where those numbers come from. All right, and the last thing we need to, this was a double replacement reaction. Yes, ma'am. So then the last thing that we need to do is balance this. Okay? So, do you want the atoms and molecules wrote down, or you just want to do the math in your head? Write them down. Okay. You can do that. Okay, so What are some elements and or ions that we see? We have some iron. What else? We have a hydroxide ion. What else? We have some calcium and a phosphate ion. Okay. Irons on our left. Irons on our right. Again, that's where it comes from, right there. Hydroxides, left. Comes from that too, right there. Okay? Hydroxides to the right. Calcium's left. Calcium's right. Phosphates left. There, right there. There's a 2. And phosphates right. That number 2 there. Okay. There's a 2 there. That's right. Okay, from that number 2 there. Okay, there's only one of 2 places to start, either your irons or your calciums. Okay, so if we have 3 irons on our right side and only 1 on the left, how do we get 3 irons over here? Multiply by 3, and that gets distributed through the entire compound. So that changes that to a 3. Okay, how many hydroxides does that give us? 3 times 2 gives you 6. Okay, so we're getting closer. Now you can look at your calciums on your right side or your hydroxides on your right side, but they're both in the same place because our irons are balanced. Our phosphates are balanced. These 2 are not, but they appear in the same position over here. So if we have 3 calciums on the left, multiply it by 3, changes this to a 3, distribute that through the entire compound. How many hydroxides does that give us then? That gives you 6. Now you have the same numbers on both sides of your equation. Okay, so remember, these were all 1s to begin with. So in front of our first compound, that was a 1, but we changed it to a what? Changed it to a 3. Right there it is. In front of our second compound, there was a 1. Do we leave that or change it? You leave it. And then in front of this compound, there was a 1, and we're going to leave it. Then in front of this compound, there was a 1, but we changed it to what? Changed it to
3.
There we go. That is now balanced. Okay? Again, some of these equations, they take quite a bit of time to go through. And that's why putting the appropriate time in is certainly useful. Anything else you'd like to add? Okay. Is more reactions, I think, do 1 more. Okay. And then have you had enough at that time? Because we still have Friday and we still have Monday. So we're not trying to push so much information in you in such a short amount of time. That's why we're doing just a little bit of a block at a time. Okay. Can we erase this? Okay. Okay. We're giving you the reaction. You need to complete the reaction. Sometimes that's what takes place. So before we go let me let you write this down first. Okay. Do any of these subscripts go to the right side? For sure. None of them, one of them, both of them? Just one of them? Yes. Oh. You're right, but I don't know if you know why you're right though. Okay. So, well, let's go with what we know. Even if this was not wrote or written here, how would you know this is a single replacement reaction? Because what? Well, not necessarily. What do you have on your reactant side that's all by itself? No, not hydrogen. Because how is this different than the reaction that we did prior to this? Because correct. It only has one element here. It's a lone metal. Last example, there was a compound plus a compound, gave you a compound and a compound. That's not the case with single replacement reactions. Okay? So, the charges would not change. This was a -3 before. It's still a -3 now. Hydrogen's in column 1, so it's got a charge of what? And lithium's in the same column as hydrogen, so that's also a +1. So where does this break apart so we can do a single replacement? Okay, so what you said is correct. This lithium replaces the hydrogen, but on this side. But of these two subscripts, do none of them go over there for sure? One of them or both of them? You said it correctly, but I don't know if you knew why you were right. Can you elaborate on that, though? Because isn't it refreshing saying you're right? But yes, you were right. Okay? Well, which positive ion do you want to start with first? Okay? So, you said hydrogen. Does that 3 go over there? You're correct. Why does it not go over there? Because this was over here to balance the compound. But hydrogen is a gas, and if it's by itself, what does that mean? You need a 2 because it's diatomic. Okay? Then what does the lithium bond to from this compound but on that side? PO4. That's right. Again, the charges do not change. Okay? +1, -3. Okay? Do we need to change anything on that side? Correct. And the reason that this 4 goes over here is because it's part of the formula. Okay, least common multiple between 1 and 3. So we need a 3 there. Okay? So, when we look at this, we've got some lithium, have some hydrogen, and then we have some phosphates. Okay, lithium left, 1, lithium right. Hydrogen's left, hydrogen's right. Phosphates left, phosphates right. Okay? So there's really only one place to start. Well, 2 places. Okay? We could start here just to see once what happens. We could put a 3 here. That's simple enough. Oops. That's not a 2 there. Should be a 3. Okay? Now, this is where we're going to have problems. Okay? Because this is an odd number. This is an even. So since these come in pairs, and this is an odd number, we need to get that up to an even number. And the best way to do that is what? We multiply that by 2. Should put parentheses there. 2 times 3 gives you what? Okay? Distribute that through the entire compound. What do we got to do with our phosphates now? Okay? Now, everything's balanced except for our hydrogens and our phosphates. And they're in 2 separate spots, unlike the last example we did. Okay, so how do we get this up to the number 6? Multiply that by 3. So that gives us 6 there. But we've got 1 phosphate here where we need to get 2 of them. So if we multiply by 2, that changes the lithium because you got to distribute it through the entire compound. So that changes that to a 6. 2 times 1 for phosphates gives you a 2. And then what we see here, pretty simple. We got 6 lithiums over here and 3 on this side, but we can certainly take this out of here and change that 3 to what? Once we do that, then that changes that to a 6. Okay? And this is where those numbers are coming from. So we had 1, 1, 1, and 1. This was a 1, but we changed it. Put a 6 here. This was a 1, but we changed it to a 2. This one was a 1, but we changed it to a 3. And then this one was a 1, but we changed it to a 2. All right. That's about 24 minutes, so I think that's about probably a good place to stop. And if you have any questions, please, some of you are getting help. Continue to do that. Front row, anything else to add? We're good? Your lab partner has answered the question. Okay. Second row. Third row. Okay. We will catch up to you next time.